Hello class. Today we're going to be looking at zeros of polynomial functions so that we can find all the zeros in our functions, and that will also translate to graphing those. So let's go ahead and dive right in. As we are finding zeros for our polynomial functions, which helps us be able to graph them, rather than if we are not told any and it's not a trinomial, we can use something called the real rational zeros theorem to eliminate some possible zeros so that we don't have to test all integers or all real numbers, because that would be infinite. So if a polynomial function has integer coefficients, and that's important that it's integers, and an integer constant, the possible zeros then are going to be found by taking the factors of the constant and dividing that by the factors of the leading coefficients. So let's take a look at what that is going to entail. So here we have a polynomial function, f of x equals 2x cubed minus 3x squared plus 5, and we want to find all the possible, and that's an important word here, possible real rational roots of this function. So we need to identify what our p is. Remember, our p is going to be the factors, the factors of 5, and over q, and that's q is the factors of 2. So our possible real factors, our real rational roots, will take the factors of 5, which are 1 and 5. But remember, we can also have positive or negative numbers. So we're just going to put that positive, negative over it. And then the factors of 2 are 1 and 2. And once again, we want to make them positive or negative. So when you're listing them, we'll do 1 divided by 1, so that's positive or negative 1. 1 divided by 2, which is positive or negative 1/2. 5 divided by 1, which is 5, positive or negative 5. And then 5 divided by 2, which is positive or negative 5/2. So we have 8 possible rational roots, which is much smaller than infinite. So here's another example. Find the rational roots of this. 3x to the 5th minus 2x squared plus 6. Once again, you'll identify the p and the q and put them over p divided by q. I want you to take a moment and pause this and see if you can come up with it on your own. And when you have an answer, go ahead and push play and check your answers. So p was 6, and we listed all the factors of 6 in the numerator, and q is 3, so we listed all the factors of 3 in the denominator. When you take the numerator divided by the denominator 1 by 1, you're going to get positive and negative of the following: 1, 1/3, 2, 2/3, 3, and 6. Now, 1 is 1 over 1, and it's also 3 over 3. Notice I didn't list it twice. You don't need to do that. We will be using that real rational zero theorem to solve our polynomial functions. A couple other things we want to know about that, though, is that about our solving is that the number of zeros, our roots or solutions, x-intercepts, remember those all mean the same thing for a polynomial, is going to be equal to the degree of the polynomial. And the degree of the polynomial is the degree of the leading coefficient, or leading term, of the leading term. And one other thing to find that we can have, so if I have x to the 5th as my leading term, it will have 5 zeros, but not all of them will necessarily have to be real. We can also have imaginary roots. But if you have one imaginary root, you also have to have a second imaginary root, because you have no imaginary numbers in the polynomial. So let's dive right in here and try to find the solutions or the x-intercepts of this polynomial. F of x is equal to x cubed plus 12x squared plus 21x plus 10. So I'm first going to find what some of my possible rational roots are. P is 10, Q is 1. So the factors of 1 are just positive or negative 1. So my real rational roots can only be the factors of 10. So it's going to be plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. And then we're going to use synthetic division picking one of these 8 real rational roots to determine, is that a factor of this polynomial. I'm going to choose 1. So I want to know, is f of 1 equal to 0? So I'm going to use synthetic division. 1 goes in that box. And the coefficients of my polynomial are 1, 12, 21, and 10. And I'll do some synthetic division here. Drop the 1. 1 times 1 is 1. 12 plus 1 is 13. 13 times 1 is 13. 21 plus 13 is 34. 34 times 1 is 34. 34 plus 10 is 44. And this is not a 0, so no, that's not a factor. And I've noticed that with my positive numbers, these numbers in the quotient just kept getting larger and larger. I need to get some subtraction in there. So let me try f of negative 1. Does that equal 0? So I'll put negative 1 in this box. Oops, let me do it nicer. Negative 1 in the box. And same coefficients, 1, 12, 21, and 10. And I'm going to drop the 1. 1 times negative 1 is negative 1. 12 plus negative 1 is 11. 11 times negative 1 is negative 11. 21 plus negative 11 is 10. 10 times negative 1 is negative 10. So this is a 0 for my remainder. So yes, negative 1 is a factor. Let's continue this. So now we do know that negative 1 is one of my zeros. And my remaining is x squared plus 11 plus 10, 11x, I'm sorry. If I set that equal to 0 and factor that, I'll find the other two zeros. So I'm going to set this x squared factors into x times x. And then I need factors of 10 that add up to 11. That's pretty simple. It's x is 10 and 1. So then each of these factors can be set equal to 0. And we get x is equal to negative 1, and x is equal to negative 10. So I have from here, I know that x is equal to negative 1. And from the answers here, I know that x is equal to negative 1 and x is equal to negative 10. So I would say that x is equal to negative 1 with a multiplicity of 2 and equal to negative 10 with a multiplicity of 1. And we have one more example here. If you want to give it a shot on your own, go ahead and pause and then come back and see the worked out solutions. But the first thing I want to do here is P is 13, Q is 1. And so my possible real rational zeros are going to be positive and negative 1 and positive and negative 13. So I really only have 4 choices, which is nice because I'm going to have 4 solutions. And because that leading term has a degree of 4, which means I have to do synthetic division twice successfully before I get to a trinomial that I can factor. So let's start with positive 1. So we want to know, does f of 1 equal 0? So I'll put that 1 in the box, and my coefficients are 1, -6, 22, -30, and 13. I didn't need any placeholders on that. So we'll drop the 1. 1 times 1 is 1. -6 plus 1 is -5. -5 times 1 is -5. 22 minus 5 is 17. 17 times 1 is 17. 30, -30 plus 17 is -13. -13 times 1 is -13, which does give us a 0. So we're going to say yes, f of 1 is 0. Now this is x cubed, right? I'm going to write it up here. X cubed minus 5x plus 17, that's x squared on the 5, 17x minus 13, and we want to set that equal to 0. Since all the coefficients are just listed here, I'm going to try 1 again. Is f of 1 equal to 0, making that a multiplicity of 2? So let's try and find out. Drop that 1. 1 times 1 is 1. -4 plus 1 is -5 plus 1 is -4. -4 times 1 is -4. 17 minus 4 is 13. 13 times 1 is 13. And so I do have a 0 as a remainder again. So this 1 is going to be a multiplicity of 2. So we know that 1 is a multiplicity, has a multiplicity of 2. And now we can take this trinomial, make that x squared minus 4x plus 13, set that equal to 0, and say, can I factor that? If you try a little bit, there's no factors of 13 that add up to -4. So you can use either completing the square or quadratic formula. I'm going to go ahead and use completing the square because I think it's a good thing to think about or to practice again. So I'm going to do x squared minus 4x, and I'm going to add something, and then I'm going to have 13, and I'm going to subtract whatever that something is, and that's going to be 0. So my b is -4, so I'm going to take -4 divided by 2, and then I'm going to square that. So that's -2 squared, which is 4. So I'm going to add 4 here and subtract 4 here. I write that polynomial, or that in the parentheses, as a square x minus 2 squared plus 13 minus 4 is 9. And then I'm going to use the square root property. So I'm going to subtract 9 from each side. I get x minus 2 squared equals -9. We'll take the square root of each side. So we'll have, I'm going to come over here, x minus 2 is equal to plus or minus, and the square root of -9, well, the square root of 9 is 3, and the square root of a negative is going to be that I. So it is imaginary, which is why we could not factor it. Then we'll add 2 to each side. X equals 2 plus or minus 3i. So my factors are -1. Let me use a different color here. +1 with a multiplicity of 2, and then 2 plus or minus 3i. So those are 1, 2, 3, 4 solutions.